All right, so what we're going to talk about today, our objective, is to understand the converse, so that's the opposite of the Pythagorean theorem. Shh, we're taking notes. To prove or disprove if the triangle is a right triangle. Or not. All right, so the Pythagorean theorem is not going to change, but how we use it is going to change. The Pythagorean theorem says you have a right triangle, therefore numbers are going to fit into these particular places, and you can figure out the missing piece. So how we're going to use it is I'm going to give you the lengths of 3 sides, and your job is to tell me, yes, it's a right triangle, or no, it's not a right triangle. If what you get when you plug in the 3 numbers doesn't give you something that's true, then it's not a right triangle. Okay? So we have a couple of examples for you to try. So the question we're going to ask, do I have a right triangle? So I'm going to give you 3 sides. Oops. I'm not going to label them. I'm just going to give you 3 sides. So we have a 3, we have a 4, we have a 5. So we're going to use Pythagorean theorem. Jacob, we're taking notes right now and you're scribbling a picture. We're going to assign A, B, and C to these numbers. Okay, so who gets to be A?
3.
Okay, and I would assign the smallest number to be A. Who gets to be B?
4.
The middle size has to be B. And who gets to be C?
5.
The longest side, always. Now, these were put in order from least to greatest. They're not always going to be that way, so you have to pay attention to it. So what you do is you put those 3 numbers into Pythagorean theorem, A squared plus B squared, and the question is, bless you, does that equal C squared? So what's 3 squared? 9. What's 4 squared?
16.
What's 5 squared? What's 9 plus 16? 25. And the question is, does 25 equal 25? So what you say is yes. Oops. It's a right triangle. Okay? Now I'm going to box up that particular combination, and we'll talk about that in just a minute. Okay? I'm sorry?
When we write it, do we have to write out triangle or can we
You can use the symbol. Unless you're writing a written response, and then you are not supposed to use abbreviations or symbols in a written response. Okay? How about 12, 5, 13? Okay, we're going to test that out. So who gets to be A in this problem?
5.
Okay, and who gets to be B? 12. And who gets to be C? 13. So the key is, let A be the smallest, let C be the largest, and the leftover is your B. Easy as that. So we'll plug those numbers into Pythagorean theorem. A squared plus B squared, so that's 5 squared plus 12 squared equals C squared. Okay, well, what's 5 squared? 25. What's 12 squared? 144. What's 13 squared? 169. What's 25 plus 144?
That's right. 169.
So, does 169 equal 169? So guess what? Yes, it's a right triangle. Okay. And I'm going to box up that number as well, or that group of numbers. And I'm going to rewrite it in order from least to greatest. Okay? Shh, Jacob. I'm going to do one more, and then we're going to come back and talk about why did I box up those. So the third example is 7, 24, or let's do 25, 24, 7. So let's assign who's A, 7, B is going to be 24, and C is going to be 25. So we're going to plug them into Pythagorean theorem, which says A squared plus B squared, so 7 squared plus 24 squared, equals C squared, which is 25. So what's 7 squared? 49. What's 24 squared? We just did that on home. 576. And what's 25 squared? Ooh, try that again. That's 15 squared. 625. So what do I get when I add 49 and 576? Ooh, look at that. Does 625 equal 625?
Yes.
Yes. So we can conclude, yes, yes, it is a right triangle. Okay? So, this one I'm also going to box up in red. I don't know if you've heard of this before. You guys should have heard it in your pre-algebra class, but things don't always work out the way that we hope. There are certain groups of numbers that will always give you a Pythagorean, that will be true for Pythagorean theorem. Anytime you have a group of 3 integers that give you Pythagorean, that meet Pythagorean theorem, these are called Pythagorean triples. Now in my geometry class, students memorize those Pythagorean triples. Because if they recognize, let's say they were asked to find the missing piece, and they had a 3 and they had a 5, and it was a leg that was missing, knowing a Pythagorean triple, they say, oh, the answer is 4 because of Pythagorean triple. Yes, sir?
I'm supposed to fill this out.
Okay, sit right there. So it just is a way of saving you time, and your justification for getting full credit is you would write PT for Pythagorean triple. Now, what's interesting with Pythagorean triples is multiples of Pythagorean triples are also Pythagorean triples. Now, 3, 4, 5, 5, 12, 13, 7, 24, 25 are the most common Pythagorean triples that show up. Also, the multiples, especially of 3, 4, 5, and a couple from 5, 12, 13 also show up. So when I talk about multiples, what I mean is this. If I multiply 3 by 2, I get 6. If I multiply 4 times 2, I get
8.
Okay, you guys are supposed to be interacting with me. 5 times 2 is 10. He's also Pythagorean triple. If I multiply 3 by 3, I get 4 times 3 is 12. Okay, Jacob. 5 times 3 is that's also a Pythagorean triple. So what I did is I took that top Pythagorean triple and I multiplied them all by the same value. The result is another Pythagorean triple. So the 3 blue and the 2 green are probably the most common Pythagorean triples that you'll see. Okay? And again, knowing them just speeds up the process of being able to answer a question. Yes, sir?
Do they usually have a pattern like that? Or,
You mean that you can do out the multiples?
like how there's a pattern like it, how it's 6 to 8 to 10, and how it's 2.
That's because of the 3, 4, 5 are one number apart. So when I double, then they're going to be 2 apart, and when I triple, they're going to be 3 apart. Yeah. So that will happen just because of the 3, 4, 5 being consecutive integers. Okay. So again, Pythagorean triples, integers only, 3 numbers that work for Pythagorean theorem and prove you have a right triangle. Okay. Now, we've been pretty glib here about having things that work. Let's try one and see if this works all the time. Because right now it seems like every time I give you something, it works. So we have 8 meters. We have 10 meters. And we have 12 meters. So our question is this a Pythagorean triple? Will I get what's on the left is equal to what's on the right? So again, we're going to assign A to the smallest, C to the largest, B to the one left over, the one in the middle.
No.
Taylor, you writing stuff down? So we get 8 squared plus 10 squared. And the question is, does that equal 12 squared? Well, what's 8 squared?
64.
What's 10 squared?
100.
What's 12 squared?
144.
Well, what's 64 plus 100?
164.
Does 164 equal 144? So what we say is no. It's not a right triangle. Okay? Yeah, that's pretty much all you get to do on these. Okay? Let's see. I think there's one word problem. So let me give you an example of a word problem since you're probably going to have some on your homework tonight. All right, so this one says, Katie is buying edging for a triangular flower garden she plans to build in her backyard. Oops. Let's write it down. If you guys aren't going to write down the problem, then you don't have a model. This doesn't make sense. So let's be quiet and let's write it down. Cameron, that means you. Oh, backyard, not background. Does everybody know what they mean by edging?
No.
Okay. A lot of times what you want to do is separate a particular area from other places. Like you don't want grass to grow into it, so you'll put up an edging. And edging can be either like a plastic, like 4 inches tall, and you kind of shove it into the ground, and it has a stopping point. So what is outside can't get through it. Edging could be bricks.
Oh.
Okay, that could be another way to edge out a garden. So you're basically making a perimeter around the garden with some sort of material. Okay, Taylor.
Yeah, we basically, like, in our backyard, we have this, like, a giant grass field.
Next, if the lengths of the 3 pieces of edging she purchased are 13 feet, 10 feet, and 7 feet, will the flower garden be in the shape of a right triangle? So these are the pieces we're going to use, and we're going to go end to end with them. So we're not going to like have one edging kind of break off in the middle of another piece of edging. We want to go from end to end to create this triangle. And the question is this going to form a right triangle? So what we're going to do is use Pythagorean theorem to test out if it makes a right triangle. So what I'm going to do is take my 3 numbers and let them be A. So 7 would be the A. 10 would be the B, and 13 would be the C. And so then I put them into the Pythagorean theorem. And I have A squared plus B squared. And the question is, does that equal C squared? So I've got 7 squared plus 10 squared. Does that equal 13 squared? Well, what's 7 squared? 49. And 10 squared? 100. And 13 squared? 169. So 49 plus 100 is 149. Does 149 equal 169? No. So it's not a right triangle. Now, it could be a triangle, but it just won't form a right triangle. So her ultimate answer is no, because we proved that you can't make a right triangle from those 3 pieces. Okay?